In this lesson, we continue talking about transformations. I want to get all the boring stuff out of the way on this video because and just get the notes out to you that you'll need to work on some things in class tomorrow. We gotta learn about properties of these transformations. So we're going to do reflections, rotations, and translations today and take a look at the properties that each of them have. There are some very special properties that they have, and you have to know about them. They're going to ask you on the exam about distance, about orientation, things like that. So we'll start with reflection. Okay, so we all know what a reflection is, and I don't want to read this and bore you to death with this, but here's the definition of a reflection, okay? But basically you could see what it is. It's a flip, right? Reflection is a flip. See how this was the pre-image, ABC. So right here is the this is the pre-image, because that's what we started with, right? Pre, and this is the image. So you can see how, and here's the line of reflection. I'm going to label that right there for you. This is the line of reflection. Every line reflection must have a line of reflection. There's a line that it's reflected over. It could be just a point reflected, or it could be a triangle or a square or a rectangle, whatever. All right? So in this case, we took a triangle, reflected it over. Notice how the distance from A to the line is the same as A prime to the line. Notice how the distance from B to the line is the same as B prime to the line. They marked the congruences there. Boom, boom. Okay, they're just showing you how it's the same distance away. C to the line is the same as C prime to the line. That's very important to understand. Okay, however, you'll also notice that this distance from A to A prime is not necessarily the same as B to B prime. This is longer than this, and C to C prime is even longer. See that? So the distance from A to A prime is different from B to B prime, different C to C prime. That means that reflections do not preserve distance. Distance is not preserved in a reflection. When they ask you, what preserves distance? Okay, you will say a reflection doesn't. Okay, you'll be picking that a reflection does not. Something else about reflections are you can have points on the line. So if the point is on the line of reflection right here, all right. See how this point P is on the line of reflection? Well, then that's also P prime. You don't move the point. If the point is on the line of reflection, it doesn't move. All right? But if it's off the line, obviously it does move, and we just talked about how that happens, okay? So here's P prime. So here's the pre-image, and here's the image, right? Pre-image, image. And here's the pre-image and the image. It doesn't move. It stays exactly there. What's orientation? Because we're going to talk about orientation of reflections, rotations, and translations. Orientation refers to the order in which we label them. The order in which we label the vertices. So take a look at we're going to use this diagram up here. I thought I was going to. Okay. Oh my goodness, what is going on here? Okay. Oh, this is ridiculous. Okay, what I want to do is erase. Thank you. Okay. So, see these triangles and the way they're labeled. Okay? Look at the pre-image. Look at the pre-image. It goes A, B, C. It goes A, B, C in a clockwise rotation. A, B, C in a clockwise rotation. It goes A, then B, then C. But look at the image. It goes A prime, B prime, C prime. It goes the other way. A, B, C. It goes in a different direction the way you label it. This is going clockwise, A, B, C, A, B, C. Look what I'm doing. A, B, C, A, B, C, A, B, C, A, B, C. See how it's clockwise? A prime, B prime, C prime, counterclockwise. A prime, B prime, C prime, A prime, B prime, C prime. Okay, so you can see that that's called the orientation is changing. The order is changing. Orientation is just the order. Okay, so we're going to go through characteristics and then we're going to just label what they are. So we just talked about what a reflection does. Distance from pre-image to image. We already said A prime does not equal necessarily B prime. Okay, so I'm just going to put C above. See the diagram above, how you can tell that A prime does not equal B prime. All right, so distance is not preserved. Is not preserved. Preserved means remains the same. So I'll just put that in parentheses. To preserve something means to keep it the same, right? If we're going to preserve something, we keep it the same. Milk has preservatives. Okay, bread has preservatives in it. Things that help it stay in the same state so they don't spoil, right? Or go bad, or they last a little bit longer. So preserve means to keep the same. Distance is not preserved because A prime does not equal B prime. The distance from A prime does not have to be the same as the distance from B to B prime. It's a little hard to see, but we're going to use our notes and do some examples tomorrow. Obviously, we're going to work on this. Orientation, we already said, is not preserved because, see above, again, the order of the labeling is not the same. Changes. You could put changes. Put in parentheses, changes, right? Order of the labeling, that says cabling. Order of the labeling is not the same. So orientation is not preserved. All right, and then we're looking for any special points on a reflection. Well, special point would be that point on the line of reflection. So point on the line of reflection right? Point on the line of reflection, P equals P prime. They're the exact same. So I'm just going to draw a picture here. Okay, P prime. If you have a point that's on the line of reflection, it doesn't move. It stays where it is when you reflect. All right, let's take a look at the next page and rotations. Try to go a little quicker here. So we all know what rotations are. It's a turn. It's a nice little diagram here to show you a rotation. This is a rotation around point O. Oh, by the way, I forgot about the notation. See how it's capital R? Capital R shows rotation. Go back here. Lowercase r shows a reflection. So see how it's lowercase r and then a little subscript m? That means reflect over line M. You just got to get used to the notation. This means reflect over line M. There's line M, okay? RO means rotate around point O. So here's our center of rotation, and the triangle rotated. The triangle was like this, and then it went like that. It went from there to there, okay? So is AA prime the same distance as BB prime? Is that the same distance as CC prime? No, it's not. Because look, C to C did not move as much as A did. Why? Because A was farther away from the center. So A had to move further. See the green circles? It kind of shows you the track it moves along. A had to move a lot further than C did for that rotation. So distance is not preserved. We don't necessarily move the same distance. It's the same degree turn, but it's not the same distance. A moved further than C did. You could see it easier with A and C. B is tough to tell, right? But you could tell A moved a lot further than C did because C is closer to the center of rotation. All right? So that's what we're going to put here. Again, distance is not preserved. We're going to draw a line down here. Distance Distance is not preserved. Is not preserved. And we're going to kind of put y over on the left. Why is distance not preserved? Okay, so we'll just say a prime. Oh, a, that's supposed to say a prime. A prime. A prime does not equal c prime. Okay, and we'll just put points further from the center, or further, yeah, we'll say further from the center, which is the point of rotation, move a greater distance. Okay. Points further from the center move a greater distance. Very hard to write on this thing, so sorry about the slop. How about the orientation? Does the order change? Does the order change? No. Look at A, B, C, A, B, C, A, B, C. It's going clockwise. How about now? A, B, C, A, B, C. It's still going clockwise. It's still going the same way. A, B, C, A, B, C. It's going the same way. It did not flip, so the orientation is preserved. So orientation is preserved. Okay, so we're going to put C above. C above. Okay, order does not change. Order does not change. All right. And special points. Center of rotation is a special point. The center of rotation is a special point, because that's what it all rotates around. Whatever that center rotation is, that's what it's all based on. So we'll talk more about that. I don't want to waste any more time in your video. Rotation direction. When you go clockwise, when we go clockwise, that is a negative rotation. A positive rotation for an angle is counterclockwise. Very important to know that. Positive rotations are counterclockwise. So this one up here, see this one up here? Of course, they're not going to let me go back up. Anyways, the one up top there, it goes counterclockwise. That was a positive rotation. Negative rotations are clockwise. Okay, something you just have to memorize. Counterclockwise is positive, clockwise is negative. And real quick, coterminal angles. Coterminal angles are giving us equivalent rotation. So if you rotate 100 degrees, now remember, 360 is all the way around. If we have 100, all you got to do is add 360 and you have the exact same rotation. All right, so I'm going to model this better in class tomorrow, but all you do is add 360. You add 360 and then subtract 360. So 100 plus 360 is 460. So a plus coterminal angle would be 460. A minus coterminal angle, we take 100 and subtract 360. So I'm going to show you what we're doing here. We're doing 100 plus 360, then we're doing 100 minus 360. It's very simple. Adding or subtracting 360 gives you a coterminal angle. That means they end in the same exact spot. Okay, so 100 degrees, for example, 100 degrees is this. There's 100 degrees. All right. If I add 360 to that, I just go around one more full time, right? I add a full circle to that. Well, that's the exact same angle. That means coterminal. Okay. And that I added 360, right? What's 100 plus 360? It's 460. So this full angle here is 460. What if I subtract 360? I just go the other way. I can go the other direction. Subtract 360. All right. If I subtract 360 from 100, I get negative 260. So angles can be negative. All right. So negative 260 is a coterminal angle. 320 plus 360 is 680. 320 minus 360. So again, minus 360 gives you what? Negative 40. Gives us negative 40. How about negative 40 plus 360? That gives us 320. How about negative 40 minus 360? That gives us negative 400. 400 plus 360, 760. 400 minus 360 is 400 minus 360 is 40. Okay, and then you could negate it again, and you can get negative 320 if you want to subtract 360 again. So these are all coterminal angles. They all end up in the same spot. And last but not least, our translation here. Okay, get you through this quickly. I know it's a long video for you. Translation's very simple. It's a slide. A translation is a slide. You could see it modeled here. ABC just slid over A prime, B prime, C prime. Translations are easy. You know why? Nothing changes. The distance is the same. Look, A moves there, B moves there, C moves there. They all move the exact same amount. Distance is preserved. So we're going to go quickly here. Distance is preserved. I think it's pretty easy to see that. Okay, we're just going to put A prime equals B prime, which equals C prime. All right. Orientation, ABC, 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 right? Goes the exact same way, clockwise, clockwise. So orientation is preserved. There's no flip. As long as there's no flip, the order, I'm just going to put C above. See the picture above where you can see where order it preserves. And there are no special points. So just put none here. There are no special points for a translation. Why? Because every point moves the same amount. You could put that in your box there under special points. Every point moves the same amount. All right, so that's it for translations. I know I went fast. Again, just getting information you need to do the work in class tomorrow. We'll see you then.